Hello everyone, my name is Dr. Amit Kumar Yadav, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana, India. In today's lecture, we are going to start some important part related to statistical machine learning. First one say non-Bayesian. It, it is used in statistical machine learning. It refers to approach that does not require explicit use-based theorem or incorporate prior distribution in their framework. This method is based on, say, frequency principle, where parameters are considered fixed but unknown quantities, and inference is based on, say, sampling distribution of the data. The key concepts in non-Bayesian methods are frequentist inference, where parameters are fixed and data is considered as a repeatable random sample from a population. Inference is made by considering the frequency or proportion of the data. Point estimate. It is used to estimate parameters using specific value, example maximum likelihood estimation. Then we are having hypothesis method. Here we can use a chi-square test and t-test to make a decision or infer the properties of the population. Confidence interval, it provides range of values within which the parameter is expected to lie within a certain probability. Classification. Um, It is a fundamental task in, say, machine learning where our more important goal is to assign a label or class to an important sample based on its features. It is divided into parametric and non-parametric, and they can be either Bayesian or non-Bayesian. So common classification algorithm, first we are having parametric method. In this method we are having logistic regression, linear discriminant analysis. What do you mean by this logistic regression? It is a linear model for, say, binary classification, and it utilizes logistic function to model probability of, say, class membership. In linear discriminant analysis, features follows Gaussian distribution, and it finds a linear combination of features that best separate the classes. Then we are having, say, non-parametric methods. Here we are having k nearest neighbor, decision tree, random forest, support vector machine. What do you mean by this k nearest neighbors? It classifies samples based on majority class among its k nearest neighbor in the feature state. In decision tree, partition of feature space into region which is associated with different class level. And in random forest, it is a symbol of, say, decision tree which is used to improve classification performance and reduce overfitting. Support vector machines, it finds a hyperparameter that maximizes the margin between classes in the feature space. Next, we are having this regression. It is used in machine learning where goal is to predict a continuous target variable based on one or more input features. There are various types of regression techniques which are suitable for different types of data and relationship between the variables. First one, say, linear regression. Here we are using say simple linear regression, model the relationship between a single features and say target variable using linear equation say y is equal to mx plus c, where m is the slope and c is the intercept. Multiple linear regression extends simple linear regression to multiple features. Then we are having this polynomial regression. It extends linear regression by adding polynomial term to model nonlinear relationship. Try to see the mathematical expression of say simple linear regression, which is used to model the relationship between two variables by fitting a linear equation to observed data. The equation is y is equal to b naught plus beta 1 x plus eta, where y is the say dependent variable, x here say independent variable, b naught is say y intercept of regression line, beta 1 is slope of say regression line, eta is the error term. Next, how we have to calculate this unknown value. First of all, we have to take a mean of say x and y. It is given by x bar, that is the mean of say data sample in x. Y bar is the mean of say data sample in y. It is calculated by this equation. Next, how we have to find out the slope beta 1. Beta 1 is given by this equation. Once we know the value of say xi and say yi, here x bar is the mean and y bar is the mean of say data samples in y, and we put all this value in this equation in order to find out the slope beta 1. After this, how we have to calculate the intercept beta naught, that will be equal to y bar minus beta 1 into x bar. Beta 1 we have calculated and x bar we know that that we have to put all this value in order to get the intercept beta naught. Then we have to uh, form the regression equation. Here y is equal to beta naught plus beta 1 into x. Now we will try to implement this on a simple question or simple example. Suppose here x having said data 1, 2, 3, 4, 5, and y is having data sample say 2, 3, 5, 4, 6. We have to calculate mean of x. Just add all the data values under capital X and divided it by 5, because here we are having number of data sample as 5. What we will get here is 3. Next here y bar, we have to add all elements of say y matrix and divide it by 5. Here we are getting 4. Now, how we have to find out the slope beta 1? Summation of xi minus x bar into yi minus y bar by summation of xi minus x bar whole square. So first of all, we have to calculate xi minus x bar into yi minus y bar. So if we take xi say I is equal to 1, I is equal to 1, here x I is equal to 1 and y I is equal to 2. Similarly, x2 is equal to 2, y2 is equal to 3. Then we are having x3 is equal to 3, y3 is equal to 5, x4 is equal to 4, yeah, y4 is equal to 4. Then we are having x5 is equal to 5, y5 is equal to 6. We put all this value here and we are getting here 16. Next, we are having summation of xi minus x bar whole square. We have to vary this I from 1 to number of data samples. Here number of data sample is 5. So we put all this value and we are getting here 10. Next here, by putting all this value, we are getting here say beta 1 is equal to 1.6. Next we have to calculate the intercept b naught. Here b naught is equal to y bar minus beta 1 into x bar. Here y bar we are having 5, beta 1 we are having 1.6, x bar we are having 3. We put all this value and we are getting here beta naught is equal to 0.2. Then we have to construct linear regression equation. Y is equal to say beta naught plus beta 1 into x. When we put all this value, we are getting here say 0.2 plus 1.6 into x. So linear regression line that best fit the data is y is equal to 0.2 plus 1.6 into x. Next, we will see multiple linear regression. The general form of say multiple linear regression model is say y is equal to say beta naught plus beta 1 into x1 plus beta 2 into x2 plus eta. Try to see here what is y. It's a dependent variable. X1 and x2 are independent variable. Beta naught, beta 1, beta 2 are coefficient to be determined. Eta is the error term. Now we will see how we have to calculate all the coefficients. Now take an example here. X1 we are having say year of experience and it is given as say in the form of data 1, 2, 3, 4, 5. X2 is a hour of training and it is given as say 40, 50, 60, 70, 80. Then Y salary in say dollar thousand. Here 50, 60, 65, 70, 75. We want to estimate relationship between Y here salary and x1 say year of experience and x2 say hour of training. Now set up a system of equation. We assume the model as say y is equal to b naught plus beta plus b1 into x1 plus b2 into x2. Our main goal is to find out the coefficient, this beta naught, b1 and b2 that minimize the sum of square error. Okay. So in step 2, we have to write this normal equation in order to solve say beta naught, beta 1 and beta 2. We set up say normal equation. We take a summation of both sides. Here summation of y, it will come n naught beta naught. Here n is the number of say data sample plus plus b1 into summation of xi plus b2 into summation of x2. Then we have to multiply this equation by x1. So it will become summation of x1 into y plus beta naught into summation of x1 plus beta 1 into summation of x1 square plus beta 2 into summation of x1 and x2. Then we have to multiply this one with x2. Here it will come say summation of x2 into y plus beta naught into summation of x2 plus beta 1 into summation of x1 into x2 plus beta 2 into summation of x2 square. Now we are having this three set of equation 1, 2, 3 and we are having three unknown beta naught, b1 and B2. We are having three equation and three unknown. So we can solve these three equation in order to find out say beta naught, B1 and B2. So we put all these equation. First we will take summation of y. We are getting here 320. Then we are having summation of x1 here. Summation of x1, summation of x2, summation of y. Okay. Then we are getting here summation of x1. We are getting here 50. Then we are taking summation of x2. Here we are getting say 300. Then summation of x1 square. Here we are getting 55. Then summation of x2 square. Here we are getting say 21,500. Then summation of x1 into x2. We are getting here 1100. Then summation of x1 into y 950. Then x2 into y 62,500. Now we have to solve the system of linear equation. We put all this value in the matrix. We are having beta naught, beta 1, beta 2, and we are getting here value 329, 50, 62,500. Now we will take inverse of this matrix, and we have to find out the constant value beta naught, beta 1 and beta 2. Now, when we solve this equation, we are getting here beta naught is equal to 67, beta 1 is equal to 1739, beta 2 is equal to minus of 87. And we put all this value here. This multiple linear regression equation, it can be written as y is equal to 67 plus 1739 x1 minus 87 x2. So what we conclude from this equation, beta naught is equal to 67. It is an say intercept, meaning when both x1 that year of experience and x2 hour of training are 0, the model predict a salary of say 67,000. Then we are having say uh, mm, here beta 1 is equal to 1739 for each additional year of experience holding hour of training constant. The model predict an increase of salary by say 1739. Beta 2 is equal to minus 87 for each additional hour of training holding year of experience constant. The model predict a decrease in salary by say $87. So in this way we have to interpret the models. Okay, so for any unknown value of x1 and x2, we are able to find out say y. Next here we are having say multiple linear regression numerical. So it extends simple linear regression to include multiple independent variables. So in this example we will use a data set with two independent variables x1 and x2. So, and one dependent variable y. So, given the following data set x1, x2 and y. So, x1 here we are having 1, 2, 3, 4, 5. x2 we are having 2, 3, 4, 5, 6. Y we are having say 4, 5, 6, 7, 8. We need to find multiple linear regression equation. Y is equal to say beta naught plus beta 1 into x1 plus beta 2 into x2 that best fit the model. So how we have to find out this coefficient beta naught, b1 and beta 2? We use this normal equation beta is equal to x transpose into x whole inverse x transpose into y, where x is the same matrix of say independent variables. It includes columns of 1 for the intercept. Y is the vector of say dependent variable. Beta is the vector of say coefficient. So we try to put all these in say matrix, say construct matrix X. It is given here, and then we have to construct Y matrix based on the variable. Then what we have to calculate X transpose into Yes. So it is just a simple matrix multiplication. So when we compute this x transpose into x, so we will get here this matrix. Then we have to compute x transpose y. So x transpose is this matrix, y is say this matrix. So when we do this simple multiplication, we will get this matrix. Then what we have to calculate x transpose into x into say a transpose here. Use a matrix calculator or now or manual computation. We will get here this matrix. Now we have to calculate say beta by using this equation x transpose into x whole inverse x transpose into y. So when we will compute this, we are getting this equation. So the multiple linear the regression equation is say we will put all this value 2 plus 1 into x1 plus 1 into x2. So this is another way how we can compute the say coefficient intercept parameter of multiple linear regression equation. So this is useful in say developing the relationship between a given set of data. Next, we will see the density estimation. Uh, why we are using this density estimation? For estimating probability distribution of say data set. It is used in say anomaly detection, clustering and say data generation. It is mainly of say two types. First one say parametric and say non-parametric. Consider this parametric density estimation. Here data follows a known distribution and goal is to estimate parameters of that distribution. So common parametric distribution here we are having say Gaussian distribution characterized by its means and variance. Then we are having exponential distribution. It is characterized by rate parameter. Binomial distribution, it is given by number of trials and probability of success. Poisson distribution, it is characterized by say rate parameters. Then we are having non-parametric method. It does not assume a specific form for the distribution and it is more flexible in modeling say complex data distribution. In common non-parametric method, we are having histogram. It divides data into bins and estimate the density by counting the number of data point in each bins. Then we are having kernel density estimation. It uses a kernel function for smoothing the data and estimate the density.